because I'm following my own notes. I have made this, and these are really good one. Okay, around 9 students have been joined. I'll do one thing. I'll directly share the PDF. I won't go with the notes. Okay, like that one note. I'll directly annotate it here. So now tell me, are you able to see the screen?
Yes, ma'am.
Yes, ma'am.
Sorry for the inconvenience that I have lost 5 minutes. Don't worry, I'll extend the class for 5 minutes. Fine. So today we are going to learn about the acid, base, and the salts. Okay. These are the notes which I have made personally for my previous students, and the same I'm using for you as well, right? So here about the acid, bases, and salts, what you should know. What is the acid? What is base? Okay. So can you give me example of acid in your day-to-day life? Each one of you have to give me at least one name of the acid. We'll just start with the introduction about the topic. Yeah. Abhinav,
Yes,
can you
ma'am.
give one name of the acid?
Hydrochloric acid.
Hydrochloric acid. According to Abhinav, the name of acid is hydrochloric acid. Its symbol would be HCl, right?
Yes, ma'am.
Yeah. Then Ionija, zinc,
Ma'am, citric acid.
citric acid. Okay. Fine. Okay. The next one, Shubhansh. Shubhansh,
Sulfuric acid.
sulfuric acid. Okay. Sulfuric acid, it will be H2SO4, correct? Yeah. Dhriti,
Ma'am, HNO3, nitric acid.
HNO3. Okay. HNO3 is called as what? Nitric acid. What is the name of HNO3? It's a nitric acid. Clear? Fine. Now, Moksh,
Dilute sulfuric acid, ma'am.
dilute sulfuric acid. Now, what is the basic difference in between dilute and concentrated?
Dilute had less acid compared to high concentrated acids, ma'am.
Okay, fine, good. Now, Dhairya, one example for the acid,
Yes, ma'am.
one example for the acid.
Um, One more example. Acetic acid, ma'am.
Acetic acid. Okay, very good. Yeah. So, on the basis of source, on the basis of preparation, method of preparation, these acids are classified as inorganic acid, organic acids, right? Yes or no? That all things we have to learn thoroughly in this chapter. We are going to learn about the acid. We are going to learn its properties. We are going to learn its reactions. Then we are going to learn about base, properties of base, and the reactions of base. Now, how we supposed to prepare the salts by using acid and base together? Because one basic reaction we know, acid when react with base, it will form salt and water. And this reaction is called as what? Neutralization reaction that you might have learned into the previous chapter. Have you learned it? Yes?
Yes, ma'am.
Yeah.
Yes, ma'am.
I hope you might have learned the types of reaction in the previous chapter, right? Yeah?
Yes,
What are
ma'am.
the
Yes,
types
ma'am.
of reaction? Tell me. First one was combination reaction.
Combination.
Yeah. Second one, decomposition. Right? Third one
Yes,
was
ma'am.
displacement reaction. That is also called as what? Single displacement. And fourth one was double displacement, right? Yes.
Yes,
Yeah.
ma'am.
Now, what I said you, neutralization reaction. Now, neutralization reaction means what? This is nothing but your double displacement reaction. Why? Because when your acid react with base, it will give you salt and water. In this also, mutual exchange of ions would take place. Right? Already you have learned about combination, decomposition, displacement, double displacement. Definition of combination would be what? I'm just doing little recapitulation for you. Combination means a chemical reaction in which two reactants combine to form single product. Correct? Yes?
Yes,
Yes
ma'am.
or no? Yeah. So in that what? A plus B gives you C in general. Right? Decomposition reaction in which single reactant will be break down into two or more simpler products. This is called as what? Decomposition reaction. In displacement reaction, what happened? One of the element or more reactive element displace less reactive element from its compound and take its place. Right? Yes or no? This is called as displacement reaction. And in double displacement, what happened? A plus B plus AB plus CD. In that mutual exchange of ions would be takes place. So A will be go with D, right? Yes. And C will be go with B. So you will get what? AD plus CD. These are your products. So what happened in double displacement? Mutual exchange of ions takes place to form two or more new products. Among that, one of the product would form a precipitate, and hence these reactions are precipitation reaction as well. You might have learned in the last chapter, right? Yes? Whatever I'm explaining, that is correct. You have learned it or not? Guys,
Yes,
I'm
ma'am.
asking you something.
Yes,
So
ma'am.
you should speak, then only we can means like you will understand the concept. When you open up, you speak up. Understand? Whatever your doubts, whatever you understand, you should speak. Now see, in acid and base, for the example acid, I have taken HCl. For the base, I have taken NaOH, right? So in this, what happened? Na will go with Cl and H will go with OH. So what you will get? Salt NaCl and water H2O. So what happened in this case? Same in this way happen or not? Mutual exchange of ions happen or not? Yes. So mutual exchange of ion in their aqueous state to form salt and water, and hence neutralization reaction is also your double displacement reaction. I don't know whether you have learned in the last chapter or not, but then it's important. You should be aware. And all double displacement reactions are not a precipitation reaction, but then all precipitation reactions are double displacement reaction. This statement is also very important. You have to write down somewhere. Shall I write it on the board? Shall I?
No, ma'am.
Fine. Please note down somewhere. Shall I erase it now?
Yes, ma'am.
Yeah. Now, a very important term which we are going to learn, that is indicator. So, you know that indicator is present to the vehicle, right? Two-wheeler, four-wheeler, whichever
Yes,
vehicle
ma'am.
you have at your home. Most of you must have. If you don't have, might be you have seen somewhere. So, it has an indicator. Yes. What is the role
Yes,
of that?
ma'am.
What is the role of that indicator? In our
It,
day-to-day life, what is the role of indicator present on the vehicle?
it shows us which direction the vehicle is going.
Yes, which direction we should go. You just indicate by like plug on that particular bulb, right, on that indicator. So the someone which is there behind you can understand in which way you want to take a turn and can drive accordingly. And so you and the one which is following you can be drive safely, isn't it? That is the purpose of indicator, right?
Yes, ma'am.
So in this case, purpose of the indicator means what? Means like what is the indicator in case of acid and base? This indicator is a substance which can distinguish in between acid and base. It can distinguish in between acid and base. Means it can show whatever substance you have, that is acidic substance or that is basic substance, right? So what do you mean by indicator? Indicator is a substance which can be distinguished in between acid and base. So here definition is given. Please note it down. I'll just highlight it. See. See here. The dye or dye stuff which can be differentiated between acid and bases are called indicators. So this is one of the important definition, and even we are going to see its classification. Please write down this definition. The dye or dye stuff which can be differentiated between acid and bases are called as indicator. What it does, it just distinguishes between acidic substance and basic substance. How it does, it will change the color in the particular solution. In acidic solution, it shows particular color, and in basic solution, it will show another color. So by that color indication, we are able to understand whether the substance is acidic substance or basic substance. Clear? Yes?
Yes, ma'am.
Yes,
Fine.
ma'am.
So classification of indicators. Indicator is further classified in around 3 types. First one would be the natural indicator, another would be the synthetic indicator, and one more type of indicator is there, that is olfactory indicator. Now, natural indicator are the indicator which are available in nature, means from the source, from where you get, right? From the source. If it will be available in a nature, okay, and that you are using to distinguish in between acid and bases, then it is called as what? Natural indicator. Okay. If you are preparing it in a laboratory for the purpose of distinguishing between acid and base, then it is synthetic indicator. Now, natural indicator have a several example. You might have seen the turmeric powder at your home, right? Yes. In acidic substance, it remains yellow, but then if it come in contact with base, it will turn red. Right? Calcium carbonate or tuna, you might have heard about. If you take that tuna and rub the turmeric in that, what happens? It will turn red. Isn't it? Have you ever examined this? Have you ever experimented this? If not, then you can do it by yourself. It won't be harmful. Right? What happened? Turmeric and calcium carbonate or the tuna, which are available in the market. Hello? What happened?
Yes, ma'am.
All of you are there? Yeah. So if you rub together, what happened? That yellow color turmeric will be turned into red. Fine. So this is a natural indicator. Rose petal is also one of the natural indicator. Apart from that, many other hibiscus rose, China rose, that is also a kind of natural indicator. Now, apart from that, if you see phenolphthalein, eosine, these are prepared into the laboratory for the distinguishing between acid and base. And such indicators are called as synthetic indicators, right? Now, the next type is nothing but olfactory indicator, which is written over here. Check. Now, olfactory nerves are present where? Can you tell me? I don't know whether you have learned it in your bio yet or not. But then olfactory nerves means what?
Ma'am,
The
it
nerve
present in onion and vanilla essence.
that is there. But then what I'm asking you, olfactory nerves means what? It's related to biology. It's not related to chemistry. Olfactory indicators means what? That you gave me answer. It's present in onion.
Olfactory nerves are present in nose.
Present
Is it
in notes, correct?
Yes.
Yes, olfactory nerves are connected with the nose. It's connected with the smell sense, isn't it?
Yes, ma'am.
Yeah. So olfactory indicators are indicators whether the substance is acid and base by showing the changes into smell. Understand? About the natural indicator and the synthetic indicator, what I told you, it is showing the changes into color, right? That we are able to see with our eyes. But then if you see about the olfactory indicator, it does not show the changes into color. It will show the change into smell, right? And the example of this will be onion pill, vanilla extract, clove oil, etc. Fine? Yes or no? And it's related to what? Smell. It is related to what? Smell. See, what about this? So, natural indicators are the litmus paper. You might have learned earlier, seen blue litmus and red litmus. Then the turmeric powder is also natural indicator. Red cabbage is a natural indicator, etc. Even the rose petal also you can add in that. The indicator which are prepared in the lab artificially are known as synthetic indicator. Examples are given: methyl orange, phenolphthalein, universal indicator. Even eosine you can add in that. Now, indicator which are differentiate the acid and base with the help of smell. This is very, very important. With the help of what? Smell is called as olfactory indicators. Right? An example, onion pill, vanilla extract, and clove oil. So these are the three types of indicator which we use to distinguish in between acid and base. Clear? Yes?
Yes,
Anyone
ma'am.
Yes, ma'am.
to understand this concept? What is indicator? I haven't understand, even not the classification of indicator. If it is so, please ask. I can repeat it. And I hope you are noting down. Are you? Are you noting down whatever I'm explaining?
Yes, ma'am.
Your running notes should be there with you, whatever I taught in the class. It should not be happen only I'm explaining and you're not doing anything. Shall I clear it? Shall I erase it?
Ma'am, wait.
Yeah, please do it. Now we are going to see what sort of changes these indicators shows in acidic and the basic solution in the next chart. That chart is also very, very important. Most of the time in MCQ and even your sorry, 2 to 3 marks question would ask on it. If you see your previous board examination paper, this part is quite important. Yeah. Shall I clear it now?
Yes, ma'am.
Fine. So we'll move little down. Yeah. See about this indicators. So we have seen the natural indicator, blue litmus and the red litmus, right? What is the characteristics of blue litmus? Blue litmus turns red into the acid and it remains blue into the base. Correct? Now, red litmus, it will be remain red into the acid but turns blue into base. Universal indicator remains red into the acid and turns remains blue into the base. Means it shows the all the colors according to the pH. Universal indicator show all colors on the basis of pH and its concentration of H plus ion, right? But then in acid it will be red and in the base it will be blue. Okay. Methyl orange, it will be red in the acid and shows yellow color into the base. Sometimes yellow or sometimes it can show orange color as well. Okay, fine. Methyl red and methyl orange show same type of the color, red and yellow. So these two like indicators you can keep with a similar result in your mind. Phenolphthalein, it will be remain colorless in the acid, but it will be turned pink into the basic solution. Right? Turmeric powder remain yellow into the acid, but turns brown or red in the basic solution. Red cabbage, it remain red in the case of acid, but then it will turn green in case of basic solution. Please note down this chart, it is quite important. In MCQ, they may ask you. Today only grade 10th result has been declared, right?
Yes, ma'am.
Good. Please note down this. And if you see your previous question paper, number of questions were asked on this topic. Indicators. This part is really very important. If you have done, let me know. Blue litmus. Blue litmus turns red into the acid, remains blue into base. Red litmus remain red into acid, turns blue into base. Universal indicators show red color into acid and turn blue into basic solution. Methyl orange and methyl red. It remains red into the acid and turns yellow or orange into base. Phenolphthalein remains colorless into the acid and turns pink into base. Turmeric powder remain yellow into acid and turns brown or red into basic solution. Red cabbage remain red into acid, turns green into base. So what you feel? Most of the indicators remains red into acid. Only for the phenolphthalein and the turmeric powder, you have to keep in your mind this change, right? And these changes also you need to keep. Basic things you need to keep it in your mind. Because here is a differentiation. Here most of the indicators show red color in the acidic solution. Fine.
Yes, ma'am.
Yeah. So shall I erase it now?
1 minute.
Yes.
Yeah.
Yes,
Please
ma'am.
hurry up fast. Erase. Shall I?
1 minute, ma'am.
Oh.
Thank you, ma'am.
Yeah. Now we are going to see a definition for acid and the base. Means first of all, acid we will see, and the classification of acid we will see. Then we'll go for the base later. Today, I hope I can complete acid at least. Yeah. See here, acid. So what do you mean by the acid? The substance which have hydrogen atom and it releases hydrogen ion in their aqueous solution are called acids. This definition you have to focus more because I'm going to give you two examples. First example is what? See, HCl, right? And another is C6H12O6. What is this? What is this? This is a hydrochloric acid, correct? Yeah.
Yes, ma'am.
And what is this? It's a glucose, isn't it? Yeah. Both these substances have a H hydrogen in that their compound. Here is one hydrogen. Here, how many hydrogen? 12 hydrogens are there. Correct? Yes or no? Both these compounds have a hydrogens. What definition says? Definition says the substance which have hydrogen atom and releases hydrogen ion in their aqueous solution. Means if I dissolve this HCl ion into the water, what I will get? I will get H plus ion plus Cl minus ion. Okay. if I dissolve it into water. So H plus ion has been released in its aqueous solution by the HCl. But then C6H12O6, if I dissolve into the water H2O, I won't get any sort of H plus ions present in that. I will get C6H12O6 plus H2O only. It get dissolved completely. We can't distinguish them. It's a homogeneous mixture, but we won't get H plus ions in the solution, and hence your glucose won't be acid, right? But then HCl is acid. Understanding the basic difference in between acid and non-acid. Acid and non-acid both can be have a hydrogen atom in their compound. But then acid is the substance which have hydrogen atom in its compound or in its itself, and can be released it as a H plus ion or hydrogen ion. If it won't release H plus ion or a hydrogen ion in its aqueous solution, then that substance cannot be called as acid. Understood? So the example is given: HCl, HNO3, H2SO4. These are the acids which can release the H plus ions in its aqueous solution, and hence these are acidic solution. Whether glucose is non-acidic solution. Most of the time in your examination, such kind of questions are already asked. Though glucose have 12 hydrogen atom, it cannot be considered as an acid. Explain why. So why it is not? Because in its aqueous solution, it does not releases H plus ion. Understand? And hence we cannot consider it as a acid. Clear?
Yes.
Yes?
Yes,
Yeah.
ma'am.
About the definition of acid, and these are the examples: HCl, HNO3, H2SO4. But then these are further classified in a different way, means organic acid and inorganic acid. And this organic and inorganic acid is completely depending upon the source, right? So acid can be classified on the factor like source, then the ionization, then the amount of water, and the basicity. These are the four factors by which we are able to classify them. First one is nothing but source, from where you obtain it. If you obtain it naturally from the organic source, then that acid is called as the organic acid. See, the acid which is derived naturally from animals or plants. If you derive it from animal or plants, then it is called as what? Organic acids. These acids are called as carboxylic acid. This organic acid have another name, that is what? Carboxylic acids. Fine. So what are the example for the carboxylic acid which we obtain from the organic sources, maybe from plants or the animals? First one is given the citric acid. Where the citric acid present? It is present into either lemon or orange. Then next one is the tartaric acid. Where is the tartaric acid present? In a tamarind. Tamarind, everybody aware? What is a tamarind? Emily? Right? Yes? Next is oxalic acid. Oxalic acid is present into tomato. Even though oxalic acid is present into apple as well. Fine. Then the next is lactic acid. It is present into either milk and curd. Then formic acid. It is present into black ant, honeybee, right? When honeybee bite us, you will get the burning sensation, right? Right? Yes or no? Why you get that burning sensation? Because that honeybee releases this formic acid on your skin. And because of that, that burning sensation would arise. Means starts. Right? And if you apply Colgate over it, what happened? You will get relief from that burning sensation. Or else if you wash it with a soap, you will get a relief from that burning sensation. That is what? Neutralization reaction. Acid come in contact with base. Soap is a base, Colgate or else toothpaste is a base. When you apply on an acid, it neutralizes the effect of acid, and hence you get relief. That same we are going to learn in upcoming sessions. Okay, these all applications and the day-to-day life uses of this acid base we are going to see in upcoming sessions. Then acetic acid, it is present into vinegar. So these are what? All are organic acids. Okay, that are also called as what? Carboxylic acids. They're obtained from what? Either from plant or animals. Okay. Right. And these are the examples. I hope all of you have written this. Yes. So first
Yes,
classification part is what about source. If you obtain it from the plant and animal, if these acids are called as organic acid have another name, that is a carboxylic acid. Okay. And examples are there in front of you. That's it. It's about the first type of classification or first form of classification. Second form of classification or second type is nothing but inorganic acid. So what are these inorganic acids? These are prepared artificially in a laboratory. Okay. The acid which are prepared artificially in a lab is called as inorganic acids. And these are also called as mineral acids as well. Right. Another way to call this inorganic acid, that is nothing but what? Mineral acid. As I told you, organic acid has a name. Organic acid has a name, carboxylic acid, right? Like that, inorganic acid has a name, mineral acids.
Ma'am,
Fine.
could you show the previous page, ma'am? I'm still writing.
Oh, you're still writing? Fine. Just give me a minute. Fine. Do it. Once you have done, let me know, okay?
Yes, ma'am.
So on the basis of preparation, if acids are made artificially into the laboratory, those acids are called as inorganic acids. Fine. And these inorganic acid have another name, that is nothing but a mineral acids. Examples are hydrochloric acid, nitric acid, and sulfuric acid. These three acids are mineral acids or inorganic acid, you can see. Now, on the basis of ionization, right? It's like those acids can be ionized 100%, right? They are called as strong acid. And those are partially ionized, that are called as weak acids. So strong acid, those are highly ionized or 100% ionized, like hydrochloric acid, nitric acid, sulfuric acid. These are highly or 100% ionized acids. And those are partially get ionized into the liquid, or else we can say into the water, that are called as weak acid, like tartaric acid, citric acid, oxalic acid, or organic acid, mostly weak acid as compared to inorganic acid. That you need to keep it in your mind.
Completed, ma'am. Thank you, ma'am.
Fine. So understood about the inorganic acid? Yeah. Inorganic acid.
Yes, ma'am.
Acids, right? HCl, HNO3, H2SO4 is the example. Now, on the basis of strength, again, we can classify acid as a strong acid and weak acid. The strong acid, which can be fully ionized into the aqueous solution, or 100% ionization will be given into the aqueous solution. Those are the strong acid, and those won't give 100% ionization, that are called as weak acid. So mostly inorganic acids are the strong acid, like HCl, HNO3, H2SO4. It is here. You can check this. These are strong acids, whereas citric acid, tartaric acid, oxalic acid, or else organic acid, any organic acid is a weak acid as compared to inorganic acid. Fine. Clear? Yes?
Yes.
All of you are with me?
Yes,
What
ma'am.
I'm explaining, you're understanding, right?
Yes, ma'am.
Now, next is what? Acid is further classified on the basis of water present in that. If a minimum amount of water is present into acid, that acid is called as what? Concentrated acid. And if it has a maximum amount of water, that is called as dilute acid. Right? If less amount of water, more amount of acid, it is concentrated acid. If more amount of water and less amount of acid, that time it will be diluted acid. Fine. And diluted acid, concentrated acid can be turned into diluted acid at any time by addition of water. Fine. And that process is called as dilution of acid. Here. The process by which concentrated acid is converted into diluted acid is called as dilution of acid. It is done by addition of water to the acid. Means concentrated acid can be turned into diluted acid by just adding water. That's it. Clear? At any moment, we can do this. Right? And the next, acid can be classified on the basis of basicity. Now, what is this? It's quite different, right? Basicity, how basicity is related to acid. That might be there in your mind, right? So what is the basicity? Basicity is defined as the number of hydrogen ion which can be released by any acid in its aqueous solution. This is a definition for basicity. This is a definition for basicity. Basicity is defined as the number of hydrogen ions which can be released by any acid in its aqueous solution. Right? Yes. So if it releases one hydrogen, one means mono, then it is monobasic acid. If it releases two hydrogen, then it is dibasic acid. If it is releases three hydrogen, then it is tribasic acid and so on. Understanding? Clear? See, once again, I'm going to explain you. What do you mean by basicity? Basicity is defined as number of hydrogen ions which can be released by any acid in its aqueous solution. Correct? If it releases only one H plus ion in its aqueous solution, then it is monobasic acid. If it releases two hydrogen ion in its aqueous solution, then it is dibasic acid. And if it releases three hydrogen in its aqueous solution, then it is tribasic acid. Examples I'll let you know. Wait. Here. First one, we are going to see about what? HCl. Right? If I add it into the water, it will be dissociated as H plus plus Cl minus, correct? How many hydrogen ions released? How many hydrogen ion released? Only one, correct? So it is monobasic acid. Correct? Another H2SO4. It will be dissociated at what? 2H plus ions plus SO4 minus 2 ion, correct? So how many hydrogen ions released? 2. So it will be dibasic acid. And H3PO4, in this case, what happened? It will be released 3H plus ion plus PO4 3 minus, correct? Or minus 3. It releases 3H plus ions and hence it is tribasic acid. Clear? Yes?
Yes.
Understood the basic difference in between monobasic, dibasic and tribasic, right? This basicity is depending upon what? It depending upon the number of hydrogen ions released in its aqueous solution. Okay, that is called as the basicity of that acid. If it releases only one H plus ion, then it is monobasic acid. If it releases two hydrogen ions, it will be dibasic acid. If it releases three H plus ions, then it is tribasic acid. Clear? If you
Yes,
want to
ma'am.
write, you can. If you want to write this, you can write. And once you are done, let me know. So that's what I said to you, like I wanted to complete at least acid classification today, that I have done. So tomorrow at the same time, we are going to start for this one, base classification, right? And then we will see about the pH. Clear?
Yes,
Reactions of acid, not pH. We are going to
Yes,
see the
ma'am.
reactions of acids. Reactions of acid, hopefully you might have learned into your previous chapter, but then we have to focus more about the properties of acid and base. Regarding that, what would be the changes that we have to see? Clear? And if you have any question from your previous chapter, that too you can ask me at any time. Do not hesitate to ask. Because what I feel, like though it is our first period, I was expecting number of questions from your side. Hardly 2 students were replying. It should not be happen. Everyone should be speaking. Okay?
Ma'am, could you share that PDF in that wise, ma'am?
I'll upload it on resource material. You can use it whenever you want. Okay? Fine. Resource material, we have a tab,
Fine,
right? That I will upload it. From there you can download. That won't be a problem. Right?
Thank you.
Yeah. So what I feel, everyone should be talkative, open up, speak up. If you have any problem, anything regarding any question, without any hesitation, please speak. Okay, do not feel like that ma'am will give answer or not. It will not happen. Definitely, I'll try to resolve your problems. Clear? So by tomorrow again, we are going to meet at the same time. We are going to discuss about the base and its classification and then the reactions of acids. Okay?
Okay.
Fine. Shall I end the class now?
Yes.
Fine. Till the time, take care, students. Bye-bye.
Bye, ma'am.
Thank you.
Most welcome.